All right, this is part 2 of our notes from section 11.2 on arithmetic sequences. Part 2 here, we're going to focus on partial sums of arithmetic sequences. And I'm just going to go ahead and give you the formulas. Um, the book does go through a little bit more on how to derive these formulas, but for time, I'm just going to go ahead and give you the formulas here. Um, the one that I'm going to focus on the most, and most of the problems that we're going to be doing, is this second one that I have the stars next to the red stars next to. So this is probably the main one. Go ahead and write both of them down. But for the problems we're going to be doing, we're going to focus mainly on the second one here. And we're going to go ahead and jump right in to this problem. If you got to pause it for a second, pause it, copy down the formulas, do that. But we're going to jump right into this first example here for partial sums. This is example number 6. You can look at it. It's on page 836 here in your book if you want to check it out in your book as well. But the problem says here 50 rows in a theater with 30 seats in the first row, 32 seats in row 2, and that kind of continues on. So the rows are increasing by 2 every time. We start at 30, then go to 32, then 34. We want to find the total number of seats in the whole theater. There's 50 rows. So we're going to use this second formula. Let's plug in what we know. Okay, we know there's 50 rows, so S of 50 is what we're looking for here. N is 50, so we got 50 over 2. 2 times A. A is the first term, or the first row. There's 30 seats in the first row. So 2 times 30. Remember, N is 50, so we got 50 minus 1. And D is the change. So how do they change? It goes from 30 to 32 to 34. So D is going to be 2. So we just got to evaluate this formula now, or evaluate this expression to figure out what's going on. All right. 50 divided by 2 is 25. 2 times 30, that's 60. It's going to be 49 times 2. 49 times 2 is 98. So keep going with it. It's 25. 60 times 98 is 158. And 25 times 158, you can do that on your calculator if you can't do it in your head. If you do that, you should get 3,950. Now what, 3,950, what does that represent? Remember back here, the question is find the total number of seats. So in this theater of 50 rows, where the seat pattern in each row goes 30, 32, 34, so on, there's going to be 3,950 seats. That's your answer to that example. I'm going to do one more example here for you. Okay, this is another problem similar to what you might see on a test or quiz coming up. This is example number 7. This is also in your book. I believe it's on page 836. It might be 837 though, but somewhere around there. But this question says, how many terms are in the arithmetic sequence 5, 7, 9, that pattern continues, must be added to get 572? Okay, so we're going to add all these numbers up. We've got to figure out how many numbers in this sequence we add up to get 572. All right, again, we're going to have to plug in what we know here into our formula. This is the same formula that we used on the last problem. We're just going to do it again. Okay, we don't know what n is here. We don't know how many terms there are to add up. That's what we got to figure out. Okay, so we're trying to figure out what n is. So at the end, we're going to have n equals whatever our answer is. But we can figure out everything else. We know what the first term is. We know what the change is. You can look and see what the change is between each term in the sequence there. So let's plug in everything we know into our formula. Got 572. Remember, we don't know what n is. We're trying to solve for that. We know we're going to have 2 times the first term is 5, so a is 5. We don't know what n is, but we know d there is 2. If you look there, the change is 2 every time we're going up 2. Alright, so we got everything we know in there. We gotta simplify this. We gotta see if we can work with this to make it look a little nicer, because right now it looks pretty messy. We'll leave the 572 where it's at. Alright, this is 10. So we got n over 2 times 10. And then I can distribute this 2 here. Let's distribute that 2 to be 2n minus 2. You can combine the 10 and the minus 2. So we got n over 2 is still out in front. The 10 minus 2 is positive 8. So let's write this as 2n plus 8. So 10 minus 2 is positive 8. Let's go ahead and distribute this. This will distribute nicely here with the 2 on the bottom. So I got 572. When I distribute here, n over 2 times 2n. The 2's cancel each other out, and n times n is n squared. Okay, let me say that again here. When I multiply this times this, the 2's cancel out, so you just have n times n, which is n squared. Next term, it's going to be positive because we got two positive values here. So n over 2 times 8. 8 over 2 is 4, so this is just going to be 4n. Okay? So that's what we got so far. This is starting to look like a quadratic. Okay, I'm going to have to solve this. So I do have a quadratic, so I'm going to set it equal to 0, and then you can either use the quadratic formula, or you can try and factor it. I'm going to try and factor it and see what we get. So I'm going to subtract 572. So I get 0 equals n squared plus 4n minus 572. Okay. Next step, let me get a little more space here so I can finish out the problem. The next step is to factor, or if you don't like factoring, you can use the quadratic formula to figure out what makes this go to 0. You'll get two answers, and we'll see. Both answers might work, or one of them might not really make sense in this particular problem. We'll see what happens. If you factor this, you get n minus 22 times n plus 26. So that tells me that n either has to be 22 or n has to be negative 26. All right. Let's go back to the question that's being asked here to see if one of these makes sense, or both of them make sense, or maybe I can take one out. The question was, how many terms in the arithmetic sequence must be added to get 572? Does it make sense that negative 26 terms are added together? That does not make sense. So this one we want to get rid of, and your actual answer here is 22. Okay, you would have to add the first 22 terms together of this arithmetic sequence to get 572. So final answer there is 22. I guess we'll write terms next to it. That's what you got to add to get 572. Let me give you some quick problems here to try and practice on your own. You can ask me about them tomorrow in class. One just like that. This is some practice. Let's see. We got how many terms of 3, 5, 7, and that continues on, must be added to get 624. That's one problem. I'll give you another one here. So that'll be practice problem number 1, practice problem number 2. Let's do a theater has 40 rows with We got row 1. We'll say row 1 has 20 seats. We'll do row 2 has 22 seats. And then that's going to continue on down here. Okay, we want to figure out how many total seats are in the theater. So try those two. If you have any questions, let me know tomorrow in class. And be ready for an assignment tomorrow in class as well.